Hi, in today's tutorial we are going to learn how to build Heatmaps video. So this would be our source image. As you can see, these three cute dogs playing with each other. And basically we will use PyTorch and YoloV8 to create these results. As you can see, it's the same video, but in this time we are pointing the object and creating a heat map where is the exact place that was detected as a dog. This tutorial is part of the object detection playlist, so this is the link for the full playlist. And also you are welcome to subscribe my channel. More videos will be uploaded soon. So let's start with the installation. We are using we are working under the Conda environment. So first of all, we will generate a new Conda environment. As you can see here, I name it YoloV8 and it will be based on Python 3.8. Then of course we are activating this Conda new Conda environment, and the next thing is installing PyTorch. In order to choose the relevant PyTorch version, first of all you have to run this command in the Anaconda prompt and you will discover what is your CUDA version. If you are not using NVIDIA GPU card, you should look for the CPU supported version in the PyTorch website. But if you are using NVIDIA GPU card, you should install as advanced CUDA, and then you will be able to look for the relevant version of the PyTorch. I decided to install this PyTorch version 2.1.1, and this is the command for the installation. If you go to the PyTorch website and go to previous version, you can find for each of those versions what is the CUDA, the supported CUDA version. And then you should install YoloV8. I decided to use this tutorial on YoloV8.1, so this is the command for YoloV8.1. And then we have to install 3 of those Python libraries. They are relevant for our tutorial. So let's go to the next step, which is coding tutorial. So let's start the coding. First of all, let's see our test video, this dog video, and we will run this video just to watch it. And once again, let's explain our target. We are generating Heatmap, so this is a visual representation used to highlight areas within the image where an object detection model has identified the presence of objects. So let's create a fresh Python code, and we will start with importing the necessary libraries, which are YOLO, and also the import object from the Ultralytics and OpenCV. We then load the YoloV8 model, the YoloV8N model, which is the nano model. And now we capture the video from the specific path. The CV2 video capture function reads the video file, and then an assertion ensures that the file was opened successfully. And next we will extract the dimensions of the frames of this video. So we extract the width, the height, and the frames per second, the FPS on the video. This information is needed to configure the video writer and the heatmap setting. The video writer helps us to write a new video with all the heatmaps. Next, we initialize the video writer, which will save the output video with the generated heat maps. The output video will be saved in the specific path. Let's store it in the same path where is the source video, so we can find them both in the same folder. In order to keep tracking, I recommend you to subscribe my channel. I keep loading video once a week, so click the subscribe button and the bell notification. So let's continue. And now we create a heatmap object. This object will be responsible for generating heatmaps based on the selected or the detected object. Then we configure the heatmap object by setting its parameters. The color map is set to color map parula, which determines the color scheme of the heatmap. The width and height of the images are passed in, and the shape is set to circle. We also enable view image, which allow us to see the generated heatmaps live. Now we start processing the video frames in a loop. The loop continues as long as there are frames to read. We read the next frame from the video. If the frame cannot be read, that means that this is the end of the video and the loop will be break. We use the YOLO model to detect and track objects in the current frame. The track function performs object detection and tracking as well. The persist true ensures that the same object ID is maintained across frames. And then we generate a heat map for the current frame using the detected tracks. The heat map is overlaid on the original frame. The heat map displayed in a window. Pressing Q on the keyboard will exit the loop and close the video. And finally, the frame with the heat maps is written to the output video file. Then we release the video capture and writer object and close any OpenCV windows. I can see here I have a syntax error. It should be is opened, ed. Great. Now let's run it. As you can see, this is the results. We are generating heat maps and it's focused on our free objects. Great results. Once again, you are most welcome to subscribe my channels. More videos will be uploaded soon. Thank you very much. See you on my next video. Bye bye.